Hey everybody, in today's video we're going to cover graphing quadratic functions that are given to us in factored form. So here we have the function y equals x minus 2 times x plus 4. So what we can do is we can start by using the zero product property to find our two x-intercepts. So I can make y equal to 0, again because I'm trying to find my x-intercepts, and I'll have 0 equals x minus 2 times x plus 4. Given the zero product property, we can make each of these equal to 0. So we can say x minus 2 equals 0 and x plus 4 equals 0. And to solve them, we will get x equals 2 and x equals negative 4. And once we have those two values, we know that our x-intercepts are going to be at 2, 0 and negative 4, 0. Let's go ahead and graph them on our coordinate plane. So to graph 2, we'll go to the right 2 and draw a dot. To graph 4, negative 4 rather, we'll go to the left 4 and draw a dot. Now, this quadratic does not have a coefficient, right? So there's no coefficient shown, which means there's an invisible 1 there. That means our pattern about the vertex table would only have two columns, and it would be labeled x and x squared. We don't need the third column 1x squared because 1x squared is the same thing as x squared. So when we have just the two columns, we can fill them in with 1, 2, 3, and 4, and you multiply those by themselves to get them squared. So you'll have 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So we have two x-intercepts. Now, we know that the graph is going to be identical on each side. So what we can do with these two x-intercepts is we can cut right in between them and draw in our axis of symmetry. So our axis of symmetry for this quadratic is at x equals negative 1. We know the vertex is going to be on this axis of symmetry. We know that this graph opens upward because we have a positive 1 coefficient that we can't see. So there's a 1 coefficient there. So to make our graph, all we need to do is simply figure out how many squares away from the center we are and work backward to find our vertex. So when I'm graphing, normally I go left and right 3 from my vertex and up 9 from my vertex. Now I'm going to do backward. Okay, so I'm going to go in 1, 2, 3, which means my vertex must have been 9 squares down from here. So I can count down 9 squares and draw my dot, and that's going to be where my vertex is. And let's go ahead and finish out this graph to make sure that my points are in the correct place. So I can go left and right 1 square from my vertex and up 1 square from my vertex. I can go left and right 2 squares from my vertex and up 4 squares from my vertex. Then I'll go left and right 3 squares and up 9 squares. And I already have those points plotted. And last, I can go left and right 4 squares, up 16 squares. I think I went off, sorry. There it is. And as you can see, we graphed this correctly because my x-intercepts fit perfectly in this quadratic graph, meaning that we calculated the location of our vertex accurately, and this vertex is located here at negative 1, negative 9. All right, let's try another one. This next one's going to be slightly harder because I'm going to be giving you one that does have a coefficient. So this one has a coefficient of 2. But we're still going to do the same process. We're going to start by finding our x-intercepts, which means y needs to be 0. So I'll have 0 equals 2 times x plus 3 and x minus 1. So even though we have the 2 there, the 2 actually does not affect the location of our x-intercepts at all. So when we do the zero product property, we're still doing these two set equal to 0, and we're not worried about our coefficient of 2 because the coefficient of 2 just tells us how stretched out our graph should be, nothing else. So you don't need to worry about it when you're doing the zero product property. For the first one, we're going to get an x-intercept of negative 3. So this will be at negative 3, 0. Let's go ahead and graph that. You'll go back 1, 2, 3 from the center. Here, we're going to get an x-intercept of 1, 0. So you can go 1 to the right of center and draw your point. Those are my two x-intercepts. Now I'm going to go ahead and draw my pattern about the vertex table. And remember, I had a 2 for my coefficient. So anytime I have a coefficient other than 1, so any coefficient that's listed, I'm going to have to add a third column, which is the second column multiplied by the coefficient. So my x squared column multiplied by 2. I can still do my regular pattern of 1, 2, 3, 4, 1, 4, 9, and 16, but because I have a coefficient of 2, I'm going to multiply my x squared column by 2 to figure out what my movement needs to be. So 1 times 2 will be 2, 4 times 2 will be 8, 9 times 2 will be 18, and 16 times 2 will be 32. So I no longer need this middle column to get my movement because I only used it to figure out what the movement from the center would be. So I'm going to draw in my axis of symmetry, and my axis of symmetry will be halfway between each of these dots. So they were 4 apart, so I would draw my axis of symmetry right in the middle, which is 2 away from each of those dots. My axis of symmetry here is again going to be x equals -1. Since I am 2 squares away from the center, that means from my vertex, I must have gone up 8 squares to get to those points. So what I'll do is I'll go in 2 squares, down 8 squares to draw my vertex. Now, to make sure this is in the correct place, I'll go ahead and fill in the rest of my table. So I'll go left and right 1 square, up 2 squares, left and right 2 squares, up 8 squares, which I already have, and left and right 3 squares, up 18 squares, which will be right here. And this fits in just right. My graph is skinny because I used integers. Integers make my graph itty bitty and super tiny. So I have a skinny quadratic because of my coefficient of 2, and my x-intercepts are at -3 and +1. Awesome. All right, let's do one more. Now, you'll notice the coefficient on this graph is negative. That means our graph will need to open down. So when we're making our vertex, we know it's going to need to be above our x-axis for it to be in the correct place. Regardless, still the same steps, so let's get started. Start with your zero product property by plugging in 0 for y, so you can find your two x-intercepts. Again, the -3 doesn't affect where the x-intercepts are. It just affects how stretched out your graph is and if your graph is located up or down. So my first x-intercept will be at x equals -2, so I can plot the point -2, 0, which will be right here. And my next intercept is going to be at -4. So I can plot the point -4, 0, which is just going to be 2 squares away from my original point. Now, to find my axis of symmetry, I'll cut between these points right in half. So they're 2 away from each other, which means that they are 1 away from the center. So I can draw my axis of symmetry line at x equals -3. Let's go ahead and do my pattern about the vertex table to figure out how many squares I need to move to get to my vertex. So I'll have x squared, and then my coefficient of -3x squared. I'll have my regular 1, 2, made a mistake there, 1, 2, 3, and 4, and then we'll connect it to 1, 2, 3, and 4, 1, 4, 9, and 16, excuse me. And then we're going to multiply that middle column by -3. So 1 times -3 is -3. 4 times -3 is going to give me -12. 9 times -3 is going to give me -27. And 16 times -3 gets me -48. Again, this middle column no longer matters because we just use it to get to our third column. And now we can go ahead and work backward to figure out where our vertex is. So from each of these x-intercepts, I know I'm 1 square away from center. So if I am 1 square away from center, I had to have gone down 3 to get to those points. So to go backward and get my vertex, that means I need to go up 3 squares to get to my vertex. And this makes logical sense because this graph opens down, because my coefficient of 3 is negative. It's a -3, meaning it opens down, so our vertex has to be above our 2 points. Let's finish graphing to make sure this makes sense. I went left and right 1 from my vertex down 3. Now I did go left and right 2 and down 12. So as you can see, this graph is nice and skinny. Itty bitty integers made this a nice skinny graph. It opens down, and my x-intercepts are going to be at